So this question is coming from the summer, that is May June 2014, paper 3 variant 2, question number 5. This is one of the questions that I have been asked a lot of times by different students on multiple years. So I thought to let's go ahead and create a video for the same. So let me go ahead and try to write the solution for the first part. They are giving us the polynomial in the format of x minus 2 the whole square times g of x, where g of x is another polynomial whole together. We have to prove that x minus 2 is factor of f dash x. Now I clearly know that with the help of factor theorem, I need to put the value of x is equal to 2 in my f dash x. And only then I can say that if it is coming out to be equal to 0, f dash of 2 comes out to be equal to 0, only then I can say that x minus 2 is a factor of this particular f dash x polynomial. Now, can I also say that x minus 2 is a factor of my original polynomial f of x? Yes, I can surely say that, because if I say that this is equal to 0 and I put x is equal to 2 in this equation, this term will go to 0 and 0 times anything is 0, right? So this indeed makes sense that if I put my x is equal to 2, my output will be indeed coming out to be equal to 0. That is the condition required for x minus 2 be the factor of f of x itself. But now with this kind of information, let us go ahead and try to solve my first part. For this, of course, you need to know how to go ahead and perform the derivative with the help of which rule? I think product rule, right? When two things are multiplied, you use product rule of the differentiation. So I can say that my f dash x is equal to, if I do the derivative of this part keeping g of x as it is, it will become 2 times x minus 2 to the power of 1 multiplied by gx. And then if I take the derivative of gx and keep x minus 2 square as it is, so plus g dash x, now this is multiplied by x minus 2 the whole square. And if I want to prove that x minus 2 is a factor of f dash x, I'll just write that f dash of 2 should be equal to 0 for x minus 2 to be factor of f dash x. So that is what I'm going to prove now. So if I put my 2 into the equation, 2 minus 2 over here will become 0, and over here also 2 minus 2 will be equal to 0. So indeed you can just do 2 times 2 minus 2 times g of x, and then you can write plus g dash x, 2 minus 2, which is again 0, the whole square. So this is indeed coming out to be equal to 0, and then you can conclude that therefore x minus 2 is a factor of f dash x. Now let's look into the second part. The second part is talking about, we are given a polynomial over here that is a quintic polynomial. We are having x to the power of 5. Over here a and b are constants, and it is given that this polynomial has a factor x minus 2 square. X minus 2 square is a factor of this polynomial. Now using the factor theorem and the results of part 1, or maybe some different technique that may come to your mind, we have to find the values of a and b. Now whenever they are asking specifically to use your answers from the previous part, it is just a hint. Even though if they don't ask this specifically, being a mathematicians or mathematics students, you should be aware about that we can always use the answers from the previous parts if it is applicable, even though if it's not mentioned. But yeah, over here it's clearly mentioned, and they've also given you an authority that it's fine. Even if you don't want to use the answers from the part 1, you can think of your own method, if at all, and try to solve this question by yourself. So let me go ahead and try to understand what is given to me. I am having a polynomial which is x power of 5. So x power of 5 plus ax to the power of 4 plus 3x cubed plus bx squared plus a. Now this can be expressed in the format of x minus 2 square, and then I need some kind of a cubic polynomial, and if I write ax cubed plus bx squared plus cx plus d, I know that if I multiply my quadratic and cubic polynomials, the maximum power that I can get is a power of 5. So basically, if you notice, this is same as this, where this is nothing but your g of x. I am utilizing the information from part 1. This is your g of x. So if you are having x minus 2 square multiplied by some kind of a polynomial, as they mentioned that g of x is another polynomial, I know in that case two things. Because here I have two unknowns a and b, I need to have two equations to solve for that. So that is why I require two pieces of information. The first information is that x minus 2 is also the factor of this given equation or the polynomial. And the second information is that the derivative of this function also has a factor of x minus 2. Now, utilizing these two information, I can solve for a and b. Let me show you how can I solve this. You can say that you can denote this entire thing as p of x. Let this be p of x. Now, what can you say? You can say that p of 2 should be equal to 0, and you can say that p of dash of 2, p dash of 2 should also be equal to 0, because x minus 2 is a factor for both the normal polynomial and also the derivative of the polynomial. So over here, let me go ahead and try to substitute 2 into my normal polynomial. So 2 to the power of 5 is 32, then 16a, then 8 times 3 is 24, then 4b plus a is equal to 0. So if I simplify this, 32 plus 24, so let me use my calculator. 32 plus 24 is 56. So 20, sorry, not 20, but 17a plus 4b is equals to minus 56. And on the right hand side, I first need to take the derivative. So it will become 5x to the power of 4, then plus 4ax cube plus 9x square plus 2bx. And now I'll put the value of 2 inside this derivative, and of course it has to be equal to 0. So 16 into 5 plus 8 into 4. Let me check the value. I'm so sorry, I'm poor at this kind of things because I've been using CAIE since I don't know, I think I was in 5th grade. But this is 32, so plus 32a, and then plus 9 times 4. I believe that is 36. Yes, it is 36. And then 2bx. So plus 4b is equal to 0. From here I can make an equation that is 32a plus 4b is equal to, what is 5 times 16 plus 36? It comes out to be 116. So this will become minus 116. Now maybe if you want, you can say that this is your equation 1, this is your equation 2. And then because you can see that there is 4b which is common, let's say you do equation 1 minus equation 2. So what is 17 minus 32? It comes out as minus 15. So minus 15a, then b's are cancelled out, and then you are having minus 56 plus 116. That comes out to 60. So from here I can say that my a value is 60 over 15 or negative 15. So a is equals to negative 4. If I know the value of a, I can substitute this in either equation 1 or equation 2. I can say that substitute a in equation 1 So you will get b is equals to minus 56 minus 17 minus 4 divided by 4, and this will come out as what? Let's check. Minus 56 minus 17 into minus 4 divided by 4. This will come out as 3. So we are finally done with this question. What is the conclusion? The conclusion is that the value of a is equals to minus 4 and the value of b is equal to 3. This will be your answer for the second part of this question. I hope this was useful.